Hi everyone, my name is Parag Paul, and this is lecture number one of the advanced courses in which we are going to discuss about the basic principles as per IS 456 different IS codes, okay, and the some facts and figures which you have to use for the Etabs software, right? So this is my module number one. Please watch the video properly, okay, and if you have any doubt, please ask. Okay, let's get started. So first of all, there are the three models what we are going to discuss. So first one is a basic principle. Second one is an analysis of RC, that means reinforced concrete structure. And the model three is the design of RC structure. Look, each and every time when you are going to design any kind of structure, you need to analyze it. Without analysis, without proper description of the shear forces and bending moment, you cannot design any kind of structure. But if you are going to determine, if you are going to analyze any sort of portal frame, any beam, any foundation, anything, whatever it is, for that you need to assign proper load. If you don't know the loading condition, you're not in a position, okay, to determine the or to do the proper analysis. So it is very important to go with the basic principle, then analysis, and then the design of the RC structure. Okay. Now, so in this model number one, my contents are type of structure, type of loading, limit state design philosophy, in which we are going to discuss about the limit state of collapse and limit state of serviceability. Then building plan and beam column arrangement, which is really very important one. These parameters, it is very important. Why it is very important? Because the wind intensity and the building rotation with respect to the nodal load. What does it mean nodal load is? Nodal load means the point or a load acting on a joint. Okay, so that kind of arrangement is very important, which we are discussing in a building plan and column beam column arrangement. Then fixing column and beam sizes and load calculations, right? So let's get start. So first one is type of structures. As you can see, there is a different kind of structures available. First one is a load bearing structure and another one is a frame structure. Load bearing structure, what does it means? In load bearing structure, you cannot find the column from the ground, which means we have column, we have the type of structure which gives us the column kind of orientation, but we transfer our load through the wall. So you can see here, you can see here, we provided the wall foundation at the bottom, and here there is no sort of column is provided, but the load coming from the top is transferred by this brick wall itself and these brick walls. So load bearing structure means the load transferred by the alternate structure or alternate conjunction, which is a similar pattern element like brick load transferred by the brick load. Okay, overall slab load transferred by the brick load. Okay, so load bearing structure, if you're going to compare with the frame structure, why we cannot design the different kind of load bearing structure in our design? Because load bearing structures are only applicable for very small height of building. If they don't want to go for a very like if they don't want to do the more expenses for their building construction, then they prefer the load bearing structure. Okay, but that building is nearly single story or double story. It's maximum double story, not triple story building. Okay, now coming to the frame structure. Look, frame structure is always consist of an foundation. Even though in load bearing structure, foundation is a main platform, but here the load transfer system is totally different. If you're talking about the earthquake engineering, so here earthquake engineering is basically deals with the frame structure. If your structure is a load bearing structure, so definitely the earthquake load will impact or it will bombard the different kind of the loading where you cannot withstand your structure properly. Okay, so now the frame structure is consist of the foundation, as you can see over here, beam, okay, then slab, then column, okay, and the top floor. So let me give some some clarification of the loading conditions. Look, I have 875 part 1 IS code, I have 875 part 2, part 3 IS codes where the load conditions are very specified. If I'm going to talk about the characteristics and the the yield stresses of the steel, that only consider in frame structure while constructing of the beam and column. But when you are going to construct the load bearing structure, in that there is no any grade of concrete is considered. But even though there is no any kind of the mechanical properties of the different steel are considered. Okay, so here in frame structure, if you consider the standard concrete, it should be like from M25 to M55 grade. Okay, and their FCK, which mean characteristic compressive strength, is which is a cube after 20 years days in Newton per mm square is, which is 25 for M25. For M55 grade of concrete, this is M55, right? And if you are go for the high strength concrete, so definitely if it is M80, so your compressive strength will be definitely 80, right? We have different kind of grades like the 33 grade, 43 grade, 53 grade for the cement. So why I'm talking about the grade? Because in StatPro or in ETAP, whenever you are going to apply, whenever you are going to create any sort of project, okay, at that time you need to assign the different kind of the material properties. For that you need to know what is a mixed design. Mixed design is very important parameter where we provide the ratio proportion of the material, like how much ratio of the fine sand, how much ratio of the coarse sand. Okay, then the what is my contribution of the cement in that ratio. Okay, that different ratio is depend. But from M10 concrete to M25, okay, you can simply analyze the M20 like mixed design, but the rest one you cannot design properly because for that very high specialization is required, and that facts and figures only calculated after testing the cubes. Okay, there is a trial and error type of things going on. Okay, if you want to learn the mixed design, I prefer you go for my mixed design video. Okay, now, so my important questions for all of you is the cement concrete reinforced with steel bar is known as the reinforced cement concrete, which we used to call as a RCC. But do you know the weight of the RCC is? What is the weight of RCC? Okay, per meter cube. Do you know in Newton? So remember the weight of the RCC, which means the reinforced cement concrete is 25,000 Newton per meter cube. No one going to talk about the different kind of the load conditions and the this kind of the weight of the RCC during analysis of the building in ETAP. And this is really very important. That's why I particularly prefer you to understand what is the load, what is the weight of the RCC per meter cube. There is a very different in weight and load. Okay, when we talk about the weight, we never talk about the gravitational forces. Okay, so this is very important one. So as we were here, so here you can see the different elements, right? This different element may consume, okay, different kind of the loadings. So on my website I already gave you the dead load calculations of the beam and column. So ETAF works on the phenomena like if you assign the self weight, even though in StatPro also, if you assign the self weight for overall building, what does it means? It means that the whatever structure you have created, that all structure will transfer their load, dead load, okay, in -1 direction. It means y direction at the bottom. Okay, because load is always acting towards the bottom, right? So whenever you are going to assign any kind of loading, you need to assign the self weight to the overall structure. But before assigning the load, you should confirm that your structure is particularly consists each and every type of the material or element which you have to design during the overall analysis. Then and only then the self load will be considered. right? So as I told you earlier also that the if you want to determine, okay, if you want to determine the weight of the bar in kg, so you need to remember the formula, which is diameter of bar in square divided by 162.2. Why I'm talking about these things? Because whenever you are going to assign the dead load, these things are very important. If you only select the dead load for overall building, does it contain the weight of the bar? If the weight of bar is not considered during the analysis of the building, it means you are not considering the 25 percentage of the steel weight load. Okay, that is very important. So how you need to do? How you can go for the overall analysis? So for that you need to assign the property in this manner. If you are going to assign the property of slab, you need to give the specification that we are using this particular percentage of the steel in this slab. Then and only then it contain this weight of the bar. Understand? Now you can see this building here. Consider if you assign the AC sheet at the top, at the floor, if you are going to assign the AC sheet, so your unit weight should be like 0.12 to 0.13 Newton per meter square. Okay, if you are going to assign the AC sheet of the 7 so your unit weight would be the 0.14 to 0.16 kilonewton per meter square. Okay, now let's come to the brick. If you are in brick, I'm considering the two different component like ballast and common burnt. So if it is ballast one, so your weight will be 6.85 to 14.30 kilonewton per meter cube. So whenever I'm going to assign the brickwork over here, I need to confirm that whatever the weight I'm going to assign for the overall, like if you consider take the wall over here which is having the height of 3 meter, how much load you are going to assign over here, that you need to calculate. Okay, or there is already per meter cube loading is given in a IS code 875 part 1. Okay, IS code 875 1987 part 1. So you can multiply that particular loading with the overall your length. Okay, so if you want to assign it on a meter cubic load, or you can use the only per metric loading and assign it with respect to the length. Okay, so it automatically assign. Right, we will see all these things, but why I'm telling all these things to you, it is very important to learn what is a frame structure. Okay, so after that, depending upon the construction of material, look, it is very important. If your structure is what kind of structure you are going to prepare, like if it is masonry structure, so your structure should be made from the brick. If your structure is made up from the steel structure, it means your building is prefabricated building. Prefab building is nowadays in very huge demand because the the big industries prefer the prefab buildings. Okay, and prefab buildings is having this particular thing used to call as a girder. Okay, and in ETAB you can see this kind of structure very easily. Even though in IB, in a stat pro also, these things are very easily can be identified and can very easily design. But for that you need an extension of an Excel. Okay, an Excel sheet you need to design, because this software only gave you the shear forces and bending moment value. Rest design scenario you need to perform. Okay, the next thing is the reinforced cement. As usual we can see. Okay, so these pictures what you can see over here, these pictures give you an phenomenal knowledge related to the type of structures, like whenever you are going to you design properly. Okay, you gave the design to your client and he is not satisfied the construction activity. Why? Because the design what you gave, the reinforcement detailing you gave to your client, but the engineer is not properly assign all the reinforcement during the construction of the slab, column and beam. So you need to go over there and look for the your betterment. And yes, the shuttering you can see the proper shuttering need to be assigned. This kind of proper shuttering need to be assigned. Then and only then your design can be called as a 99% success. Okay. Now let's come to the types of loading. As I told you, there is a uniformly distributed load and the concentrated load given in the IS code 875 part number 1 and part number 2. Basically, part number 1 is a dead load, which is a unit weight of building material and stored material. Okay, you can use for the highway construction activity also. There is no issue for that. Live load is specified in IS 875 part 2 1987. So here you can see, I will share you the file with you after 2 3 videos. Okay. So here you can see always, as I told you, how you can going to design assign the load. Always the loading condition will assign in the pattern of the concentrated load, uniformly distributed load, uniformly varying load, the moment, the torque. Okay, and this time in this type you can assign the load. That's why in clause number 3.1, 3.1.1 and 4.1.1 gave the different imposed floor load for the different occupancies. Okay, and is always in kilonewton per meter square. If it is concentrated load, okay, it always in kilonewton. Okay, now you can see the wind load which is given by the IS code 875 part number 3, where there is a total different spreadsheet we have to assign, because this kind of calculation is you will never get anywhere. Okay, so we will particularly design the along with the area. Okay, we will look for the area, in which area we have to focus, in which area we have to emphasize, which area we have to select. Consider if you are selecting the Mumbai is related to the coastal area, because we have the very the coastal area nearby the Mumbai. Okay, so their wind intensity is very high. Okay, wind intensity is very high. So what kind of wind load we are going to consider for a Mumbai? Okay, that we will look. Okay, in our coming videos. Now, the earthquake load. Look, the earthquake loading is the IS code 1893 part number 1 2002 is very important. Okay, to understand the earthquake loading. Without earthquake loading, we cannot understand the functions and the formula for the assign of the earth. So in the design approach, there is a three different methods. First one is a working stress, second one is a ultimate load, and third one is a limit state. Nowadays, we are only using the limit state of method for largely construction. But if you're talking about the pre-stress, okay, water tank and staircases, we prefer the working stress method. Okay. Now, what is a philosophy for a limit state of method? It is very important to know. So first thing is to assess the load, dead load and other external load and forces likely to be applied on a structure. As I told you, we have to identify that how much amount of load we are going to assign. Okay, that important portion come under the limit state. Then second one is to determine the design load from the different load combinations. As you know that the IS-45 always provide and combinations for the dead load plus live load plus wind load plus earthquake load. Okay, with different factors, factor of safety, okay, ultimate factors, these different kind of the factors we have to use. Why? Because if you are constructed the home in 2001 and you are going to construct the home in 2009, okay, so you are going to again construct the more two-story building on your existing structure. What does it means? It means that you are again and again applying the load on the existing structure. That's why we make the factor of the present structure, right? So our factored the function is 1.5. So whatever if your load is 10, like the current load is a 10, so you will multiply that 10 with 1.5. Okay, so your load will be 15, right? So you will design accordingly 15 kilonewton. Now, third one is to estimate structural responses like bending moment, shear forces, and axial thrust due to the design loads. So, in limit state of design, we only estimate the responses, we only go for a design after the estimation of the responses like bending moment, shear forces, and axial thrust. Without that, we cannot do the design. Okay, and the last one is to determine the cross-sectional area of the concrete section and amount of reinforcement needed. As usual, the BOQ. Okay, the total amount of quantities. let how much amount of the concrete in meter cube required for the 10 meter cube of the beam. Okay, how much amount of the steel we are going to assign for the 2 meter of the beam or 2 meter of the cantilever beam or the total 1000 square feet slab that we need to assign. Then the important question is what are the limit state? Okay, so limit state is the acceptable limit for the safety and serviceability requirement of the structure before failure occur. It means that we are providing few limits which satisfy the safety and the serviceability of the structure before failure occur. Okay, if without occurring the failure, we first ensure that there is this kind of safety and serviceability we are assigned, right? Now the next one is the design of structure by this method will thus ensure that they will not reach the limit state and will not become the unfit for the use for which they are intended. So first thing is we know that we are using this particular structure for this particular kind of loading, so in that we can ensure is it fit or unfit for that particular kind of structure or that particular kind of the behavior of the structure. If these things are satisfied, this particular thing it means to bring the safety and bring the serviceability in the structure, that means that particular thing is called as a limit state. Okay, limit state means it provide a limit for a certain area. Now after that, there are the characteristic strength and characteristic load that we will discuss in my next video. So I think if you watch this video properly, watch it again, okay, and ask me the question, whatever you have. Okay, have a nice day. Bye bye.